facing this end of your center hole. Leave about 1 to 2 inches outside the chuck jaw. Make sure the all 3 jaw contacting the Next step, we're going to turn the bar stock down to 0.975, which is the nominal size or desired diameter for the hammer handle. And we're going to slide it almost all the way out. And you want to use the hook roller to, we want to turn the diameter down for a length of 10 inches. So we want to measure 10 inch and this should be okay. You want to leave minimum of 10 inches, maybe 10 and a half or 11 inches out. Tighten the workpiece. Then we will use the hook roller to measure 10 inch from the threaded end. Draw the hand wheel towards the left until you see you get a 10 inch long pasta. This is it. So from the toe tip to the end of the circle. Now we engage the knife center. Make sure the left center have a firm contact with the center hole. Now we're going to manually scribe a line at 10 inch. We have visual reference. Now we also want to have a reference on the hand wheel which drive the carriage. So we set this position to 0, so we know exactly where we want to stop. We're going to take a test cut for about 1 inch to set up the right depth for our final diameter of 0.975. So before we don't want to take the very first cut directly to 0.975. Instead, we'll take a very shallow cut and help us set up the right depth. Find the surface first. You can see we just barely touched the surface. The high spot on the surface, actually just this portion. Majority of the surface still not touched yet, but we're going to use this as our starting point. We set this to 0 on the dial for the hand on the dial of the hand wheel for the cross direction, and that's our 0. Now we can wheel in the cross slide 10 thousandths in. That will give us ideally it's going to reduce the diameter of the stock to 0.990, but we are not sure about the accuracy of the tool setting, so we don't know yet. We're going to take a test card, measure it, and decide how much further we want to take in order to get the exact 0.975 inch in diameter. Just need to be long enough for us to take a decent measurement. And what I got is 0.984. So 18 thousandths more. Oh no, not 18,000 more. I want to go to 0.975. Right now it's 0.984, so 9 thousandths more. So don't trust your first cut, it may not be accurate. So instead of go, theoretically we should go another 15, but instead based on the measurement I only need to go in another 9 thousandths. And we're going to take the card all the way. Now we have the right tool. We also want to measure 9/16 from the threaded end using hook ruler. Get it out of the way. I measure 9/16. 9/16. Stayed 16. 9/16. This time I measure from left to right. Well, when I move the hand wheel, go from right to left because that's consistent with the machining of the paper. Just mark the line for 9/16. We also set the 0 for the dial on the hand wheel. And in addition to that, we're going to engage the taper attachment. This is the taper attachment. So we're going to, if you take a close look at the, now I'm trying to manually move the tool to touch the workpiece, just barely touched it. I'm going to set this to be my origin 0, and if you move backwards you will see that the gap is getting bigger and bigger, so you can tell that we are not travel along the axis. Instead we made a small angle with the axis. So that's how we make the tapered surface. So the goal is to make this tapered surface, and eventually we want to reduce the diameter at the neck to 0.5 or ½ inch right here at the neck. To begin with, so right now if you move all the way to the right, the tool will just barely touch the surface right at this ending point. So we want to cut a little material, so we want to fit the depths in. So we're going to use 50 thousandths each time, and we start with the rough cutting condition. Use the relatively large feet to increase the productivity, 0.0084. I'm going to move 50 thousandths in. And I will bring the tool close to the surface. Let's see what we got at the neck. I read 0.519, so 19 thousandths to go to get to ½ inch, 0.5 inch right here. So we're going to move in another 19 thousandths along the cross direction. The other thing that we need to change this time, since this is going to be our last cut, finish cut, we're going to change the feed to a slower feed, 0.0025, and we'll perform the final cut. exactly 0.5 inch. The next step, we're going to turn this diameter down to 0.61, and before we do that, we want to disengage the taper attachment, so we won't make a tapered surface on that part. We want a cylindrical surface on that part with a diameter of 0.61. Once we release this tool bolt, now if you move the carriage, the taper attachment is going to go with it, so the movement is going to follow the bad way. And we're going to start with rough cut again, just to make the process more efficient, quicker. Okay. And each step each pass we're going to take 50 thousandths off. So estimate we are going to take 7 passes, 7 pass rough cut followed by a finish cut, but I will double check probably in the middle. Like for instance, take 4 cuts, then measure the diameter. Six 627, 610, so 17 thousandths more, so we go 10, 17, and this time it's the final cut, we change to slow feed. Next task is to propel this portion, make a cylindrical surface of diameter 0.375 so that we can make thread on it, and this thickness of this part have a thickness of 1/8 inch. Okay, that's 1/8 inch. And also we want to set the 0 for the setup. Okay, we had a mark, visual reference, we have a accurate reference. Now we're going to turn this diameter down to 0.375. Right now we have a diameter 0.61. 74, so it's almost perfect. Now we want to make a very small chamfer at the threaded end. Thread relief will be cut right here, and the thread with a diameter of 0.333329 between these two numbers, and we want to change the speed. We want to use speed for threading. Oh no, sorry, the grooving. GKP 160. Right on side. Okay. Next step, we'll be using a die to make thread on the surface, on the threaded end. And in order to make the thread perpendicular to the axis of the rotation, we want to have a reference surface which will be perpendicular to the axis, and this surface is the perfect surface to be used for that purpose. To add the flat end at the tailstock, and in order to prevent chips goes into it, I use some paper towel. Manual rotation towards now, since it's already engaged. We will mark the total length of 9 and 4/4 from this end.